Shaquille, are you there? Hey, Vaibhav.
Hello, hi sir. Good morning.
I thought I'm not audible. Okay. I think Shaquille is off desk, but he joined in, it seems. Okay, maybe we can start. So, first thing first, this poor guy, Ashwini, is not even able to join in.
Yeah, he told today he
Yes.
will try, but
Okay.
yeah,
What? He got a new job or what? What is that?
yeah. He told he got new job and the shift timing is different. I mean,
Uh,
in day general shift, I think 9 to 6.
okay. That's the reason. Okay, so let's see what is the status of Kubernetes cluster. Okay, it's active. Now my instance is also active. Let's connect to instance. 40.
So in putty in connection there is some default timer. I'm not
What
sure
is
what
that?
timer is set. Okay, 0.
Seconds
Okay.
between keep alive 0 to turn off. Oh, okay. Shall I
I will
make it
check. Maybe I'll
Sir,
1000?
check.
Hi, Shakil.
sorry, I was away from my laptop.
Okay. Keep seconds between keep alive 0 to turn off and anything else to turn on or what? Um, let's see. Let's keep it 1000 this time. Okay. Accept. Let's do it. User. Let's increase the font. Okay. And then, where is a document? Notepad. Okay. What is the name of Kubernetes cluster? Demo EKS one. Change the name. Demo EKS one. Run this command. Update the config file. Next thing is, let's go to VPC. Or security group directly. Because if I won't do this, then certainly this AWS will charge me a lot. So it's important for me to just close everything every day. Okay, now we are good. kubectl, get nodes. Okay, we are good. So now what are the things which we did yesterday? Yesterday we did couple of things. Yesterday we were able to work on this and we created this replica set yesterday, right? So let's create, as of now, nothing will be there because I had to recreate it. kubectl apply -f replica set. Let's apply it. Okay, created. Now when it created, what is going to happen? It will end up creating a number of different pods and a number of different other things in it. All right. So till replica set, it's clear. I hope is there any doubt till replica set? Okay, I'll take that
Yes,
as a no.
all good.
Okay,
Yeah.
all good. Very good. So now let's move on to next step. Now after replica set, what comes is service, because that is the another layer. We have seen yesterday a couple of things. We have created pods. We have just fetched details of pods based on labels, and in case if you want to see more details of the pod, because now what is going to happen is how many nodes you do have. You see, kubectl get pods, sorry, get nodes. We saw that we do have two nodes, right? Okay, three nodes we do have now. Three nodes we do have. So now what we learned when we were talking about this demo, what we learned was the idea behind having pod is the pod will be distributed across all the nodes, right? And how many pods has it created? kubectl get pods. It has created two pods. So it doesn't mean that both the pod will reside in same node, right? The idea behind it is to distribute the pod across multiple nodes so that there will be proper load balancing also. Now, in order to check which node, which pod belongs to, you will use another flag, which is -o wide. -o stands for output. So I'm just detailing the output of kubectl get pod. So kubectl get pods gives me this output, but I want to have a detailed output, wider output. So I will use the flag -o wide, and I'll get detailed output, wider output to it. And with this wider output, I'll be able to see which node these pod resides in. So now if I hit enter to this command, what it is going to give me is, you see, it is going to give me the node details also. So now at this point, what I can see is this both the pods reside in same node, which is 𝐸70, both the pod resides in same node. It might happen that tomorrow when you create more number of pods, maybe out of you ended up creating 10 pods, and the load in one node is too high in such situation, then it will be distributed across other nodes also, right? We'll see that in our upcoming discussions also, how the pod gets distributed in different nodes. But in short, if you want to see which node your pod resides in, then you use more detailed output. You get more detailed output, because many times what happens when you troubleshoot, being a DevOps engineer, troubleshooting will be a part of your job, wherein you have to troubleshoot which node these pod belongs to and what is the status of that node and all. Sometimes you have to do it manually. And in such situations, you have to execute similar commands to understand which node this pod belongs to. Right? So you'll have to do this also. Another important command. So now, once you get this, what is the next layer? The next layer in our diagram is service. So why service is important? Let's understand that properly. And I want to just elaborate it a bit. I will take a moment and I would like to elaborate it a bit, because I said that service is going to be of three types: cluster IP, node port, and load balancer. It is very much for you to understand what are these three different types of service. So now, what is the use of service in the first place? Let's understand that. So what is the use of service? Service, you have created Kubernetes cluster, you have created pods, that's fine, and you have also deployed Nginx application in the pod. So basically, these nodes, the node is hosting one application. What is that application? Nginx application. So ideally what should happen if I come to this place, this taking the IP address of this specific node, this is the node. Which node is having this Nginx pod at this point of time? Let's see. kubectl get pods -o wide. So this is my pod. The pod resides in 8E7D, and this pod holds which application? kubectl describe and give the name of the pod. Describe pod and give the name of the pod to see what is present within the pod. So now what I've done, I have executed another command, kubectl describe pod, to see what is there within the pod. Now I did not log in into the pod. Yesterday I've shown you how to log in into the pod, how to get into the pod. Now I'm not into the pod. I'm still in my virtual machine. You see my IP address. But when I executed the describe pod command, it has just described the content within the pod. So if you see, there will be something called image or something called the application type. You see the image. Image is Nginx. So the image which is present, the container which is present within this pod is of the type image as Nginx. And what is Nginx? We have already seen that in our Docker session. Nginx is a web server. And what is web server? That also we discussed in our Docker session. So now being a web server, we should be able to access it on web, which we did in our Docker session. We have accessed Nginx application on web by using my application URL, by using my, sorry, not application URL, by using my instance URL. We did that. So now I should be able to access this Nginx also, right? Why? Because this Nginx is already creating a pod and this pod is up and running. You see the status of the pod is up and running. So ideally I should be able to access it. So now which node is this? E7D. Let's see what is E7D. E7D, E7D. There should be E7D also. Let me just refresh this. Yeah, E7D. You see, E7D is here. So I'll take the public IP of this node and I'll expect that I should be able to connect to Nginx application like the way I did in Docker also. Let's see. No, it's not taking. It's not taking. It's saying that check the proxy and the firewall. And how about this? I'll put a port number 80 also to check because Nginx default port is port 80 like the way we learned earlier. Still, it's not connecting. And the concept is very much same, the one which we learned in case of Docker. You remember, right? Docker networking, capital P, small p concept.
Yes.
Yeah, concept is exactly same. Here it's unable to connect because where is the container? The container is within the pod. My traffic is not reaching to the pod at this point of time. My traffic is blocked on the instance level itself. There is no connection in between. There is no connection in between instance and pod,
Pod.
right? That connection I have to create. Now in Docker, it was by using capital P, small p, we have created. Here, there is bit different way, more advanced way is here, more advanced way. So I'll just talk bit theory on this. Docker service, Docker service. So like the way I said, Docker service is of three types: cluster IP, cluster IP. Second is NodePort. Third is of type load balancer. Third is of type load balancer. So now what are these three? Let's try to understand it. So cluster IP, like the name says, IP of the cluster. Which cluster? Kubernetes cluster. What we have created at this point of time with this diagram, what you had learned earlier, that we are going to create a cluster. Kubernetes cluster. This was the architecture which we learned earlier. Now the name says cluster IP, that basically means IP of the entire cluster, right? IP of the entire cluster. Now, what Kubernetes says is this cluster IP will be used for pod to communicate with each other. Like when we create instances having two kind of IPs. What are the two kind of IPs? Public IP and private IP. Any of the instance you see here, and try to understand this very nicely because this is very important. So now here you see each of the instances having two type of IPs. You guys are networking folks, so you will understand it very much nicely. There are two types of IP which any of the instance gets: public IP and private IP. What is the difference between public IP and private IP? Private IP is the IP which another instances in your on-premise terms, I'll say, if you are connected by using WAN network or LAN network, then, if two machines are connected over LAN network or WAN network, then and only then they will be able to communicate with each other with a private IP address. There should be some sort of connectivity. LAN connectivity, WAN connectivity, VPN connectivity, Zscaler type of connectivity, some sort of connectivity. They should be in same platform. Then and only then they will be able to connect, communicate with each other with private IP. But any outsider, for example, your company has hosted some server, those servers will be able to internally communicate with each other because they are connected over LAN. But I am outsider. I want to access. I won't be able to access by using the private IP address. What I'll need a public IP to access the application which is hosted on those servers, right? So similar to that, what Kubernetes says that cluster IP type of service will be used by pods internally to communicate with each other. I, being the outsider, will not be able to access any of the application present in the pod by using cluster IP. Those are private IP for the Kubernetes cluster. So I can say cluster IP is like private IP for, and this is very important interview question also, private IP for Kubernetes cluster. I'm just abbreviating Kubernetes as KTS. So private IP, cluster IP is private IP for Kubernetes cluster. Now, by default, what Kubernetes has done when you have launched Kubernetes, because internally what is going to happen is when you set up the Kubernetes cluster, by default, Kubernetes has created one cluster IP service for you. In order to see which all service you do have present at this point of time, the command is kubectl get svc. So what are the commands? Kubectl get rs is the command to check how many replica sets you have. Kubectl get pod is the command to check how many pods you do have. Third command which I'm introducing in terms of listing all the resources, which is kubectl get svc. Now when I hit enter, what it is going to say me, that already one cluster IP type of service is created. But see this IP, this decides, right? I mean, you know it, right? That this decides which IP family this IP address belongs to. 10 dot is always a private IP address. It cannot be a public IP address, right? So now it's a private IP address, and this IP address will be used by whom? This IP address will be used by pods to communicate internally with each other. If two pod has to talk, why two pods will talk? Two pod in the same cluster. For example, like the way I explained yesterday also, front end, back end. Amazon's front end, middleware, and back end. If they have to talk with each other, how they will talk? They won't go to public, because in that way, what is going to happen? Who knows, there is some hacker is sitting and ready to steal your data. Who knows? So what they do is there is always a private connectivity in between different layers, in between different tiers, in between, not different environments, in between different tiers, so that what they do is these pods could be easily pass information or pass data from one sort of interface to another sort of interface, right? So this happens by using cluster IP. I'll give a quick pause. Any doubt till here? Ask me, please.
Yeah, a lot of confusion with this concept.
Ask me.
So there's going to be only one IP?
Mm, you can have more than one cluster IP. So Kubernetes does not put any restrictions how many cluster IP you can have. But what you have to do is now you have to associate these cluster IPs to the group of pods which you have created. Yesterday, what you have done, you have created one replica set, get rs. And in this replica set, what you have done, you have created pods also. What you have to do is, as of now, these pods are not associated to any service, right? And that is where you are not able to access Nginx application on the web, on the browser. Now, any of the service which we are going to create, we have to associate. As of now, it's dissociated. There is no connection. Uh, Once you create the service, you have to associate that service with the replica set. Now, since replica set is a top level service, top level object, now, as any service gets associated to replica set, automatically the underlying component of the replica set, which is pods, containers, will inherit those services and will get exposed to whatever type of service you are choosing. The first service which you are going to choose is cluster IP type. Now, with the cluster IP type, all the pods which belongs to this replica set will start communicating with each other by using the IP which you are going to associate. We'll see that how to associate, but yeah, on the high level, like what you asked is whether all the pods will be using this cluster IP. No, not necessary. You have to associate. You being a DevOps engineer have to associate, have to give instruction to pod which IP to use, which IP not to use.
No, what I'm trying to understand is like how can they communicate using with one IP only? Uh, well, since we're from networking background, so we're just thinking that one pod will have its own IP, and then the other pod will have its own IP, so they can communicate.
Okay.
So this is where the confusion is.
Yeah. Okay. Fine. Your confusion is very much fair. So now you see what happens is in terms of networking, I'll explain you. Think it in a kind of public facing application. For any public facing application, what you do, each of your virtual machines can have separate IPs, right? Yes?
Yes.
Yes. Still, what you do is you create one load balancer. And what you do with the terms with load balancer, you allow all external traffic to fall first on load balancer.
Yes.
Traffic falls on load balancer, and then it gets distributed to separate instances. But still, each instance is having one IP, right? But
Exactly.
but all the traffic is falling where on one single load balancer IP. Load balancer is also having IP. So all
Uh-huh.
the traffic is first falling on load balancer IP. And load
Yes.
balancer routes it to separate instances. Right or wrong? That is what you do being a networking guy,
Yes.
right?
Yes.
Yeah.
That's the concept we have.
Right?
Yeah.
Right? Now coming to your point. Yes. Each of the pod is having its own IP, but this cluster IP is acting as a kind of gateway. Now,
Okay.
say in case if different pods has to communicate with each other, what each pod will do? Each pod will not just keep pinging IPs of other pods because they even don't know IPs of other pod. What they know, what you are associating, what you are telling to each pod, hey, you only should know one cluster IP, this one. Now they just reach to this cluster IP, and it's the responsibility of cluster IP now to route the traffic to all other IPs. Got it, right? So consider that this cluster IP is acting like a one external load balancer IP, but since that is a public facing application, that is a public facing public IP which you are associating to a load balancer. But in this case, it's private IP wherein each pod do have its own IP, but they only know cluster IP. They are sending all their data, they're sending all the communication to cluster IP, and cluster IP is routing it across to all other pods which is present within the cluster to which this IP is associated.
Okay. And
Make
how would
sense?
they? Yeah.
Uh-huh.
Yeah. This is so the bottom line of the question is uh, the cluster IP will distribute the traffic to the pods using what?
Using service. How load balancer distributes traffic to all the instances using what?
Like how cluster IP is going to find out that I should send this one to this pod and this one to this pod.
Okay. So again, I'll come back again to the basics of how the traffic gets routed. The traffic in terms of networking itself. The traffic gets routed in two ways. First, either it's called the called the FIFO basis, wherein what happens is any of the instance which is available at any point of time where there is lesser load, where there is lesser, where there is more resources available to grab the information, to grab the resources, to grab the traffic, it gets routed to that. Other way is sticky method. In case of sticky method is what happens in each of the traffic which you want to route to instances or you want to route to the server, you give some server specific data bit which is a part of your your octet which you form, which is a kind of binary octet which you form, there in the traffic packet. You just associate some sort of sticky bit, and that decides in which instance or which server the traffic has to go. In our situation, what happens is, in our situation it's not going to be that complicated, because we are not talking about any external facing pods. Normally what happens is, in case if any of the IP is private or any of the communication which happens in house, we do not bother much about security, or we do not bother much about who gets what. So in our situation, in cluster IP situation, cluster IP will just look which pod is having how much resources available, which pod is now available to take the traffic, whether it is able to whether it is able to just process the traffic, process the transaction, process the request, which is with the basis of the request which is getting raised from any other pod, and it just routes it to that, right? So it's not that super complicated like the way we do it in load balancer. Know that sticky traffic routing method, know that packet formation method. It mostly based on the resources which the pod will have, the availability of the pod. For example, if there are 4 pods, already first traffic, the traffic came already, the first pod has some sort of process going on, some sort of applications running, or some sort of transactions going on. Still we do have 3 more pods available. So now this cluster IP will route the traffic to second pod, and if second pod is also consumed, third pod, third pod is also consumed, fourth pod. In a kind of serial fashion, it will keep routing the traffic. A kind of round robin method it follows. Understood?
Yes, sir. Thank you.
Okay. Any other question?
Sir, just one thing for me. This cluster IP, it is dynamically assigned, or we are
We have
selecting
to.
this IP, or it will
We
get.
can select. Very good question. Very good question. So yes, we can select it. We can, because and it's very valid point, because many a times what happens is, it's not as in you can choose any IP. As of now it's 10.100.0.1, because this is the IP this is one of the IP which is present within the VPC. But now many times what happens, networking team says that, hey, physical networking team says that you do have only one IP available, and will you be able to use that IP? You have the method. You will be able to associate any single IP also. You can do that. Either of the ways is fine. For example, like in case of um, not that similar, not that good example, but in case of Docker, what you have done is you were able to select a specific port also, and second thing, you wanted Docker to assign a port of its own choice. You have both the flexibility. Similar to that, in this case also, you can choose a specific IP, and you can just ask Kubernetes to assign a kind of private IP for you. Either of the thing is possible.
Yeah. Okay.
Okay. Any other question? Okay, cool. So now what you know is, this is cluster IP, right? This is cluster IP, and in case of, okay, still it's breaking. In the cluster IP, what happens is you get a private IP. Now let's try to create a cluster IP. Now again, remember, cluster IP is private. It won't allow you to have public access at all. Always remember this. right? Always remember this. So now let's create some sort of code for cluster IP. So let me just restart it. And cd and will now create one svcci. svcci stands for cluster IP, or I'll write cluster IP. But I just hope that theory part is clear and it's very important for you to understand. Now again, I'll go back to kubernetes.io. Take this help because you never know which API version is changed. So always try to refer this documentation and just type service. That's it. This is what you have to do. Okay. You have to just type. The remaining thing Kubernetes will give you. See what it says, expose an application running in your cluster behind a single outward facing endpoint, even when the workload is spread across multiple backends, right? A service for exposing a network application that is running as one or more pods in your cluster, right? So this is basically exposing your application. Come down and let's see the code. So basically this is how the code looks like. So what is the API version? Let's try to understand this code. So what, see, three, four things: API version, kind, metadata, spec. I said you yesterday also. You have to write these four things, right? You have to write these four things. So you can, again, in camel case, see, in camel case, A is small, V is capital, right? A is small, V is capital. So always you have to ensure that you're writing in this way only. Write multiple times so that you will get used to it. API version. And which is the API version? Now I'm just referring this document. I'm not remembering anything. I even cannot remember because there are plenty of API versions. Nobody can remember in this universe. There are so many API versions, and tomorrow, in case if Kubernetes changes it, nobody can remember it. Right? So you have to refer Kubernetes document. So now V1, second thing is service S capital. Remember, S is capital for service. Kind is S capital service. Now after that you write metadata, and after that you write spec. All in same line. Remember, all in same line, indentation, spacing you have to adhere. Metadata, name, spec, these are the things. Let's try to understand now properly. What is this thing? So metadata, anyways, this is simple. This we have seen plenty of times. So name is demo SVC. Let's try to understand spec, and this is going to be interesting now. So now you see what happens. Yesterday we have seen, while we were writing replica set, we have seen selector, match labels, right? So what was the reason why while we have seen that selector, match label, sorry, we did not, I think we have seen match labels, and what we have learned was that with the use of match level, a query is getting raised. A company is raising a query that, hey, employee with the name Shekhar and experience 6 years, please come. Right? Please come. Now, what I'm going to talk about here is, I said you a few minutes back that any of the IP you will not be able to use. Any of the IP will not be associated to your replica set. Any of the IP will not be used by your pod. Rather than that, what you have to do is you have to ensure that a specific IP, a specific cluster IP, your pod, your replica set will be using, right? Your pod, your replica set will be using some specific IP. So what you have to do, you have to tell your service that, hey service, get associated to this replica set, right? You have to tell your service that get associated to this replica set. Now, how this service will know which replica set to associate with? What do you think? Any kind of, just give it a kind of wild guess. How this service will know which replica set to associate with? I should define something within this. I should raise again some sort of query which will be consumed by this service so that it will understand, okay, fine, this is the replica set which I have to associate with. What sort of query, what can I use for that? Give it a
So,
thought. Mhm.
sir, I mean the services and that cluster IP we can mention.
No, no. Tags, labels,
Yeah,
right? How my boss will know that I am the one who is working under him? My tag,
tag.
right? My
Yeah.
ID, my label. Simple. So here also I'll define the tag, that label. That's it. It's done. So what are the labels we have used yesterday? I forgot. Let me just see. What is the label I've used yesterday? The label was app as this and this. If I'm not using this, remember, then ref service will not know that this is the replica set which I'll have to associate with. Whichever label I'll be using, that label it will get associated to. Remember that, right? Remember that. It's label, it's my ID which decides which company I work for. You cannot just enter into any company with somebody else's, some other company's ID. They won't allow you because they don't identify you. They don't identify you. Even the security person who is sitting outside the door, they do not know you. What they know? Your ID, they know, right?
So
So
label means tag.
label means tag, yes.
Okay.
So now this is what I'll be using. So now under specification, like in this, let's check the syntax. Under specification, it's selector. Again, I'll give two spaces, selector. And under selector, what I'll do, I'll mention, right? I'll mention those labels. Spaces are very important. Okay. Under selector, I'm mentioning those tags, right? Under selector, I'm mentioning those tags. This is this is a part by means of which service will understand, okay, fine, you are free to associate, you are free to work on this, you are free to get associated to any replica set which is having this tag. Any replica set which is having this tag, you get associated to that. What is the next? Ports and these things. Ports, these things. So now what is this port? Actually, what I feel is for um, for um, for this for cluster IP, I don't need this target port. I'll explain you why. What are these ports? So let's first start this thing, which is port. Let's first start with this port. So now what I have to do is I have to I have to tell I have to just give some definition. I have to just open some port also within each pod so that communication can happen through that port. Like the way we did in Docker, since Kubernetes is like advanced version of Docker, in Kubernetes for internal communication also, you have to say, you have to define some port. Now, in order to do that, what I have to do? While I'm creating this manifest file, actually the very good example will be your Docker file. You remember when I was writing the Docker file, what I've done? I used a term called expose, right? I used a term called expose in Docker, and with the use of expose, what I had done, I had opened a port in the Docker container. That doesn't mean that that doesn't mean that the the Docker the application which is present in the Docker will be accessible publicly using that port. Even though I created container using Docker file where I used a keyword called expose, I had to use capital P and small p in order to expose the application publicly. Similar to that, here also, I'll use some keyword to which I'll say as ports. And under the port, I'll define two ports. I'll define two ports. Here they have defined three ports. Sorry, here also they've defined two ports only. Necessarily, I was talking about third port because third port will be used in node port and in case of load balancer type. So basically, there will be two ports. One port is the port of the pod. Another port is port of the container. Now here you see what is happening. Let me quickly draw a diagram for you so that it will be even simpler. Now you see, I am a user. Try to understand this very nicely. If you'll understand networking, you can just play with it. So understand networking will be very important for you. So consider this is my computer. I'm a user, right? Consider I'm a user and this is my computer. So consider this is my computer. What is this? Draw. Oh, can I draw something? Maybe I can use a pencil. Okay. So consider this is my computer and I'm sitting here and I'm working on this, right? I'm sitting here, I'm working on this. Now what is happening? This traffic will fall where? This traffic will first fall on, this traffic will first go and this traffic will first fall on the virtual machine. This traffic will first fall on the node, right? This traffic is falling on the node and this node is having, consider that within the node, there are containers, pods and all. So within the node, what are the things? Within the node, I'll just create those diagrams outside, but think that it is inside. But you think that it is inside. I'll draw that outside just for simplicity. So there are two pods, which is inside, which is inside the, which is this. There are two pods which is inside the, right? There are two pods which is considered these two pods are within these virtual machine. And in this pod, I do have containers also. So consider within this pod, what I have, uh, there is no diagram. I'll make it a circle. Okay, consider this is, you're not circle.
Sir, I need to ask you just a basic question.
Okay, go ahead.
So node is actually the virtual machine.
Yes.
So node equals virtual machine equals instance.
Yes.
But when we are working with Kubernetes, we don't call that instance. We call that node.
Node of the cluster. Yes.
Correct or
Node of the cluster. Yes. So in Kubernetes, we have cluster. In cluster, wherever it's not only in Kubernetes, I think, wherever you have the concept of cluster, they use this term. This is a technical term, which is very commonly used when you do have cluster of some servers. They don't call it servers directly. They call it as node of cluster.
Yeah. Usually in
Okay.
VM, they refer node, virtual machines. Yeah.
They call it as node.
Okay. Thank you, sir.
Okay. So now what happens? Consider that this outer one is pod. This one is pod, right? This outer one, what is this? This is a pod. This is a pod. And this one is also a pod. And inner one, this is a container. Okay. I'll give the name of for the container as C. C. I'm not going to type it. Okay. But the inner circle is container. Try to understand this. If you understand this, it will remain in your mind. So now what has happened? What I'm trying to do, I'm trying to access the application which is within the pod and within the pod within the container, right? So first thing, what happens? Where my traffic will fall? My traffic is not falling on the pod because pod is where? Pod is here. Pod is somewhere here. So this pod is somewhere here, right? This pod is somewhere here. This pod is where? This pod is also somewhere here. Okay, this pod is also somewhere here. So these two pods are within the virtual machine. What is this? This is my node or virtual machine or whatever name you give it. This is node or VM or instance, whatever you want to say it, right? So now both the pods are present. Where my traffic will fall? My traffic will not fall directly on the my traffic will not directly fall on the pod. My traffic will fall here, right? My traffic is falling here and it is getting blocked here because there is no public access. But internally, if they have to talk internally, then the application which is present in this pod, say consider this is C1, this is C1, and this is C2. So in case if C1 wants to talk to C2, what C1 will do? C1 will first come out of some container port, right? Some container port. Now this container port, again, the traffic will come out to pod port, and from pod port, it will go to this pod port, and then it will enter through this pod port and come to this container port. See the sequence. Application is within each container. Container 1, container 2. The application in container 1 wants to talk with application in container 2. What will happen? The traffic or the some sort of query will come out from container 1 using some gate. And what is that gate normally? In IT, in servers, what is that gate? Port. Port is the gate. So now by using container port, traffic will come out. Again, it will be hit by pod port, pod gate. So in pod also, we do have a port. From that pod port, the traffic will go to another pod port. From another pod port, the traffic will enter and will go to container port. And within the container C2, there is an application and they will talk with each other. Though it will happen in micro milliseconds, but this is the path which each of the traffic has to follow. Clear? This concept is clear?
Yes, sir. Sir, can there be more than one container within a pod?
Yes, there can be more than one container within a pod.
Okay. In that case, how would they communicate with each other?
Normally what happens is, in case if you do have a more container, there is a reason. We don't create more than one container until unless we want containers within the pod to be closely binded. And the term is called sidecar. This is the term, and this is very high level term. You don't need to know it at this point of time. This is normally used in mesh and service mesh. This is very, very high level. But what happens in case of service mesh is we create two pods. In one pod, what we do is we run some scripts. And that script, what that script does is that script enables networking, enables some sort of service component in another pod, right? So they have to be closely binded to each other. For example, in very layman terms, think it this way. If you are working on a task and you alone able to finish it. So what you will do? What you will do in that case? You will need someone who will be able to help you in that task in close association. Because every time when you are stuck, you want that person to help you, right? You don't want that person to speak with other individuals because that person is helpful to you only. It's a kind of close association you create with another individual so that you are able to complete, you are able to accomplish your task completion. Same thing we do in case of pod also. We create multiple containers within the pod, but the only work of another container is to help the primary container. So there are two containers, primary container, secondary container. The task of secondary container is just to help the primary container and not to communicate with any external containers. There has to
Yes.
be some close association.
Okay. So generally, in general practice, we have only one container within a pod.
Yes, general practice
Okay.
is that.
Okay. Okay.
Okay.
Uh,
So
Sir, this flow is clear. I mean, the instance and the pod communication, but you also shown the communication between this pod to pod.
pod
I
to pod,
mean,
yes.
so
Yes.
that also we need to establish that communication, or
Yes.
automatically
Yes.
it will be
No,
okay.
with the use of cluster IP, you have to do that.
Okay.
Yeah. So with the use of cluster IP, now you're defining two ports because you want pod to pod communication. You don't want any external communication, right?
Yeah. Yeah.
So what you will do, you will expose two ports now. One is the target port. What is the target port? Target is container only. So
Mm.
that is the target port. That is one of the port. And another port is to which the term is just port. So there are two terms, port and target port. Port is the port for, and this is the term which is coined by Kubernetes. Port is the port of pod, and the target port is the port of container, right? Port is the port of pod, and target port is the port of container. This is how it works. So now coming back to this code, you see here, the port is the port of pod and target port is the port of the container. And here the protocol which it's following for communication is TCP. So three things we have to define: protocol and two ports. Why two ports? Now you know why two ports. One will be container port, second will be pod port. Normally we keep both the port as same. We don't keep pod port and target port as different because that creates lots of confusion, right? We don't keep these ports as different. So you also try to follow similar sort of practice. Try to keep both the ports as same in your, when you start working, try to keep both the ports as same only. Okay.
Do we
So now
use well-known port or for?
normally we use application specific port, like for Nginx default port is 80, for
Okay.
Tomcat, and for another HTTP we use 443. So for HTTP, sorry, HTTP 80, HTTPS 443. So similarly application specific port we use.
Okay. Yeah. So well-known port. Okay.
Yes. Okay. And this guy again pushed me out. I'll have to figure out why this is pushing me out. Same being given and and now what I'll do is cd. Okay, I'm already in Kubernetes. vi as we see cip.yaml. Okay, now I was talking about specification. Under specification, what I have to do? I have to define two things. All right. I have to define two things under specification. What will be the first thing which I have to define? The first thing will be, right? The first thing will be your protocol, and then it will be right. And then Okay, I missed selector also. Selector. Okay, and again, I forgot what are the selector. What are those things? What was the query label? Label should be exactly same, right? You cannot put any different label. It should be exactly same as this, not even a spelling mistake with this. Selector, and this is the selector. And after selector, what you have to do? You have to define ports. Ports, right? You have to define ports, and under ports, you have to give two things, three things: protocol, port, and target ports. I'll copy this. Protocol TCP port, and I'll keep target port and port is same, right? Target port and port is just understand the logic so that you will be able to create things on your own. See, it should be properly oriented and it should be same as syntax. Now let's create it. Now let's create it. Right? Let's create it. Now in order to create, what you will do, kubectl apply -f svc cip dot yaml created. Now if I execute the command kubectl get svc, you will see that there is second uh, second cluster IP also created, and this is the IP which is assigned by, right, which is assigned by Kubernetes. But like the ways you said, I said you will be able to assign a IP of your choice also. There is a way to assign a IP. Let's see in case if there is the way which these guys have followed, but there is a definite way wherein you will be able to assign address type as IPv4. You see, endpoints and addresses are given. Different IPs, but this does not look good to me. These are endpoints. There should be some IP thing. Let me see in case if it is there. The syntax should be here. IP. Choosing your own IP address, you see, choosing your own IP address, selector dot cluster IP, there should be syntax. Yeah, cluster IP. This is the way. Let's create one with this. This is the syntax. Cluster IP. Let's copy this and
Sir,
Mhm.
little confusion. So first we had the private IP 10 dot something, 10.100.0.1.
Uh-huh.
We created that cluster IP.
Which one?
Why do we have two now? Maybe I've missed something.
Yeah, you absolutely missed things. So what I said is, and I explained it very clearly at the time, that by default, when you set up Kubernetes cluster, Kubernetes assigns or creates a cluster IP. So this is the one which is created by default by Kubernetes at the time we set up Kubernetes cluster.
Okay. And the port it took automatically by default 443?
Yes.
Okay.
This is the one which we created just now. And it took
Okay.
a
So
random IP.
oh, okay. So why do we not use the default cluster IP and create our own?
We can use. But I just wanted to demonstrate you how to create one. You can use
Okay.
this.
Okay. Thank you, sir.
Okay, now another way to assign a port of our own choice is by using this, right? By using this. Let's see. Let's try to assign this. Now, this is to answer Webhub's question, wherein he asked that, can we assign a port of our own choice? Yes, we can do that. So let's do that. vi svc cluster IP custom.yaml. And what I'll do is, rather than writing everything, what I'll do is, I will just copy the file, and then I'll edit it.
Sir, but every time you are creating new version of this YAML file, right? I mean,
Yeah,
previously it was.
yeah. Every time I'm creating a new, because every time you are adding a new feature,
Yeah.
so you have to create a new. Yes. So now what I'll do is, as we see CIP custom, now I'll give a different name to this. I'll say custom, and here I'll use exactly in this way, in the same line as ports. It should be in the same line as ports and cluster IP, right? I just gave it. Save it, come out. And now you run it again. kubectl apply. As we see, what happened? Oh, apply -f. Okay, what it says is network IP does not match the range which I have for this
Yeah.
VPC. So maybe I can come here and check what is the range which I can use. So I do have a range. Within that range only I have to use. I cannot use any range. Let's see which range I can use. Let's see. You will be able to
We
find
have
it by using
to be
CIDR range.
more careful, like, I mean, that duplicate IPs and other things
Yeah,
while
yeah,
assigning.
yeah. You have to be very careful when you're doing this. So let's see what is the CIDR range we have for this. 172.31.0.0/16.
16.
So maybe I can use something here. I can use 31.1.0. I can use that 172 dot 31.1.0. I think I'll be able to use this. Fail to allocate the provider
You
network
can
to
use
So
one, sir, there
dot
instead of
zero,
zero. 1.1,
not valid.
or maybe 100 or something. Not sure
okay,
if that IP used somewhere.
1.100. No, is invalid. It says that the invalid value for the IP, the provided network does not match the current range. Hmm. Let's see in case if my
If we
cluster
drag,
have.
sir, on the right side, I can see some IPs. Okay, that is the same one.
What is the CIDR range?
So, sir, if this is 172 range IP, how come the system gave us from the 10.0?
See, those are range of all the private IPs which Kubernetes is able to allocate by default. I mean, we do have so many private IPs. Perhaps in that range it allocated one. So let's do one thing.
Uh,
Let's go
this,
close. Let's go
this
closer to the one with system
is,
level.
but it is assigning from class A, and that
Yeah,
class B. I mean, 172 is.
different class of IPs. Let's do one thing. let's try to put something which is closer to which system is
10
assigned.
dot, yeah.
Yeah, maybe 197. 196 is something which system assigned. Ah, it worked. Okay. I think we have to be very, very careful when we are assigning these IPs. So now, so normally what happens is these IPs will be provided by those on-premise networking guys. And what we do is we just will be able to put in into this. Now you see, it got the IP which I have chosen. So yeah, you can associate IP of your choice also. It's clear. Any questions, any doubt till here? Couple of things which we have seen today. Yeah, go ahead, please.
Sir, here, but a bit confusion now. So we have 3 clusters. So among this cluster, we have to select any of the cluster IP to map between the pod and the instance, or I mean,
You are already mapping it, right?
okay.
When you are just using this, you are already mapping it to whichever selector you will choose. This IP will be associated. Now you have 2 IPs for this cluster, for this replica set. This IP is also associated to same replica set. This IP is associated to same replica set. So you can use either of the IPs.
Okay.
Any other question? Okay, I'll take that as a no. So now tomorrow we'll see even the advanced form, which is the deployment in Kubernetes cluster. But you guys started practicing it, right?
So sir, now we can we'll able to access this from remotely, from the cloud.
No, you can't because that is cluster IP,
Okay.
You will tomorrow we'll see NodePort.
Okay.
And we will see the third form, which is load balancer. And then we will be able to access it from cloud, over web.
The internal communication machine. Yeah. Okay.
Yeah. Okay, cool. So you guys started practicing, right? No?
This week, I have lots of activities. But yeah, this recording session I'm going through during my office time. But yeah, practice I have to log in on my personal laptop, which is not happening this week. So this weekend I will go through. Saturday, Sunday also I have some activities in data center. So difficult, but yeah, this weekend we'll finish all this practical.
Sure. Yeah, practice because these things are critical. If you won't
Yeah.
practice, manifest is not that simple. It's very complicated. If you won't write, definitely you will mess up.
Yeah.
Okay, cool. Then thanks. Let's connect again
Yeah.
tomorrow. Tomorrow we'll see another 2 type of services. Thank you.
Okay. Yeah. Thank you.
Thank you, sir.
Bye.
Bye-bye.